Good evening, class. Welcome to Miss Lamro's dining room. Yes, in the back of that, if you're asking, is a photo of all the characters from Inside Out, all the different emotions. That's probably what you feel like when you're solving equations. So I decided to make it a little bit easier for you and show you another way of solving equations using pictures, because sometimes pictures make it a little bit easier and numbers are a little bit confusing at times. I mean, eventually we'll get there. So let's start with this equation in yellow. You see an equation there. Some of us are like, I don't know what that means. Well, that's okay. Let's just pay attention to our objective first of all. We want to know how to get variables on one side of the equation sign and integers on the other side of the equation side. Doesn't matter which side, we just want them separate from each other. And then when we're done with that, then we can determine what the value of one variable would be. So let's start by looking at what our variables are. Well, in this case, our variable is that x, and there's 3 of them. But instead of that x, since x can be confusing, we're going to go ahead and replace that with our triangle. And I'm going to go ahead and draw a line through my equal sign to allow us to see the different sides. Well, on the left side, it says -4. That means there has to be 4 negatives here. And on my right side, I see 3 triangles, which is 3 times the number. Well, then there's got to be 3 triangles here, and then 2 positives here. Now we're going to go back to our objective. Our first objective is to get the variables on one side and integers on the other. If that's the case, where are the variables? Well, the variables are on the right side. So if they're on the right side, why don't we just leave them there? What else is on the right side? Well, there's those 2 positives. Do we want those 2 positives there? No, not really, because our objective is for the variables to be on one side by themselves. So how do I get rid of 2 positives? Well, I'm going to take the opposite sign, which is 2 negatives. And I remember that my properties of equality says that if I put 2 negatives on one side, I have to put 2 negatives on the other. And then now we're taking a look at our left side again. On the left side, I notice that I have 4 negatives, and we put in 2 more negatives, and we end up with 6 negatives. Then I look to my right side, and I notice that there's still 3 triangles. We didn't do anything to them. But then we see these 2 positives now have a negative underneath them, 2 negatives actually. So a positive and a negative make a 0, or 0 pair, and another positive make another 0. So the whole thing ends up being 0. And now we're left with 6 negatives is the same as 3 triangles. Well, remember that our objective is to make sure that we end up with 1 triangle and how much it's worth. So if 3 triangles is the same as 6 negatives, well, all I have to do is split them into groups of 3. So I'm going to take my 6 negatives, 1, 2, 3, 4, 5, 6, and I split them into groups of 3. Now, I know that 3 triangles is the same as 6 negatives, but I only want 1 triangle. So 1 triangle is going to equal 2 negatives. And there you have it. So what I'm going to have you do right now is I'm going to project the next slide and allow you to give it a shot. And you can practice your drawing. So at this point, I want you to pause me and try the problem. All right, here we are. Next slide. Don't forget to go over your objective first. Your objective is to get the variables on one side and the integers on the other. Then determine what the value of one variable with me. All right, go ahead and try it. All right, I'm pretty sure you tried it at this point. So let's go ahead and change our variables. In this case, it's a 4x. We're going to go ahead and put in a triangle here. And then we're going to go ahead and draw what this represents. We have 4 triangles. So I'm going to draw 1, 2, 3, 4 triangles, 2 negatives, and then we have 6 positives on the other side. Whoops, there we go. There are my 6 positives. And then we're going to go back to our objective. What is the objective? Well, I want my variables on one side. So that means I want my triangles on one side. Are my triangles on one side by themselves? Well, the triangles are on the left side, but then I also see those 2 negatives. I don't want those 2 negatives there. So in order to get rid of those 2 negatives, I have to put in 2 positives. And property of equality says that if I put in 2 positives here, I have to put in 2 positives on the other side as well. And now that we have that done, we can go back to the left and look, well, did we do anything with those 4 triangles? Nope. Did we do anything with those 2 negatives initially? Yes, we did. We put in 2 positives, and we know that a positive and a negative is a 0, and a positive and a negative is a 0. So this is gone. It disappeared, became a 0. And now we look on our right side, we end up with a total of, it was 6 positives, and we added 2 more positives, it gives us 8 positives. So now we have 4 triangles is the same as 8 positives. But keep in mind, we really just want to know how much one triangle is worth, or one variable would be. So in this case, if I have 4 triangles is the same as 8 positives, I'm going to go ahead and split the 8 positives between the 4 groups. So we're going to give them 1, 2, 3, 4, 5, 6, 7, 8. And now we know that one triangle is worth 2 positives. Well, that's it. Thanks for watching. Have a good evening.